Okay, so we are going to factor trinomials where a is greater than 1. So what that means is that this number here, our a value, is no longer 1. It's greater than 1. Okay, so we have a, b, and c. Okay, this is not new. So our a value is positive 3. Our b value is negative 2. Our c value is negative 5. That's nothing new. This is what we were doing all last week. Okay, so what adds to b and what multiplies to AC? What adds to b and what multiplies to AC? So what adds to negative 2, I shouldn't have drawn that line there. What adds to, let me fix that. What adds to negative 2 and multiplies to a times c? What's a times c? What's 3 times negative 5? Negative 15. Okay, so that's the only difference is that when you multiply a and c, because a is no longer 1, you're actually going to get a value that's not just your c value. It's multiply a times c. Okay, so what multiplies to negative 15 but adds to negative 2? Let's try to figure that out. Of course, my factors of 15 are 1 and 15. 15 does not evenly divide by 2. It will evenly divide by 3 with 5. Does not evenly divide by 4, so we're going to skip 4. And my next integer after 4 is 5, which I already have. And so that's my factors of 15 is just 1 and 15 and 3 and 5. So now I need to figure out what two integers do I need that would multiply to 15 but add to negative 2. Well, if I'm multiplying to a negative number, then that tells me that one of my numbers need to be negative. So to give you a visual, I'm going to have negative 1, positive 15, positive 1, and negative 15. Okay, this is just for you a visual. And then if I have positive 3, I'm going to change that to negative 3 and have positive 3 and negative 5. Okay, so I have negative 1, negative 15, negative 3, negative 5. Because negative 1 times positive 15 is negative 15. So what do they add to? Okay, all of these integers multiply to negative 15. But this adds to positive 14, because I'm looking for negative 2. Negative 3 plus 5 is positive 2. Not going to work. I need negative 2. 1 minus 15 is negative 14. Not going to work. I need negative 2. 3 minus 5 is negative 2. Ding, ding, ding. So I need 3 and negative 5. I need 3 and negative 5. So my answer is going to be written again as two binomials. Two binomials. The only difference in writing your two binomials today versus last week is you're going to write it in the form of a variable plus your number, positive 3. A variable plus your number, negative 5. You've got to include your a, and then our variable here is p. So 3p plus 3, 3p minus 5. And then simplify. 3 and negative 5 is not going to simplify because 3 is prime and 5 is prime. But 3p and positive 3 will simplify because I can divide both terms by 3. So I'm going to simplify 3p plus 3 to p plus 1. So p plus 1 times 3p minus 5. And that is your answer. That is your answer. So really the only steps that are looking a little different is this step here where you have to multiply AC. And then this step here where you have to write in a variable. And then this step here where you simplify. So it's not a whole lot of difference than what I taught you last week, but you do add a couple little extra steps with these trinomials. Okay, number 2. I'm going to post this on Classroom for y'all to go back and view if you need to. All right, number 2. I've got A is 2, B is 3, and C is negative 9. So what adds to B, what adds to positive 3, and multiplies to AC, multiplies to 2 times negative 9 is negative 18. So it adds to positive 3, but multiplies to negative 18. My factors of 18 are, of course, 1 and 18, 2 and 9, and then 3 and 6. And then I'm going to stop there because 18 does not divide by 4. 18 does not divide by 5. And then my next integer after 5 is 6, which I already have my factors of 6 and above. Okay, so now I need to figure out what numbers do I need. I'm in that same situation that I was in on the previous number. I'm multiplying to a negative. If I'm multiplying to a negative, then that means one of my integers here has to have a negative because a negative and a positive multiplies to a negative. Okay, so if I put negative with 1, that's going to give me negative 1 plus 18, which is 17. Not going to work because I need 3. If I put negative with 2 and I add negative 2 and 9, that's going to give me positive 7. Not going to work. If I put negative with 3, that's going to give me negative 3 plus 6. That's going to give me positive 3. That's what I need. So you can stop there. Now you can also list positive 1, negative 18, positive 2, negative 9, positive 3, negative 6. Put the negatives with the 18, 9, and 6. And you would still see that that would be negative 17, which wouldn't work, negative 7, which wouldn't work, and negative 3, which wouldn't work. We need the two integers here, okay? So I would write my two binomials. I'm going to write them down here since I have space. A is 2, my variable is n. A is 2, my variable is n. So 2n minus 3 and 2n plus 6. I can't simplify 2 and 3. Those are both prime. But I can simplify 2 and 6 because I can divide both terms by 2. So my final answer is going to be 2n minus 3 and n plus 3. Simplify this to 1, and then 6 divided by 2 is 3. And that's your final answer. Okay, this should come to you pretty easily if you understood last week's lesson. All right, number 3. A is 3, B is negative 8, and C is positive 4. So what adds to B, what adds to negative 8, and what two integers multiply to A times C? That multiply to 3 times 4 is positive 12. So let's list our factors of 12. Our factors of 12 are, of course, 1 and 12, 2 and 6, and 3 and 4. And we're going to stop there because my next integer after 3 is 4. Now at this point, I need both of my integers to multiply to a positive, but add to a negative. So if I'm multiplying to a positive and adding to a negative, that's going to tell me that both of my integers need to be negative. Negative 1 times negative 12 is positive 12. Negative 1 plus negative 12 is negative 13. Well, that's not negative 8. Negative 2 and negative 6 is positive 12 when I multiply. And when I add, it's negative 8. Ding, ding, ding. Those are my two answers. And I'm going to go ahead and do these to show you that those aren't the problem. Negative 3 and negative 4 multiply to 12, but they add to negative 7. Not going to work. So my two integers that I need is negative 2 and negative 6. So I'm going to come over here, and my binomials are going to be A, 3, variable n, so 3n minus 2, 3n minus 6. 3 and 2 are prime. 3 and 6, I can divide both terms by 3. So I'm going to simplify to 3n minus 2 times n minus 2. 3n minus 2 times n minus 2. And that's your final answer. All right, I'm going to do one more like this, then I'm going to do one more that has a GCF. All right, so number 4. Number 4. Let me see if I can squeeze over here some more. I can. All right, number 4. A is 5, B is 19, and C is 12. So what adds to B, what adds to 19, and what two numbers multiply to A times C, which in this case, 5 times 12 is going to be 60, positive 60. So what two numbers multiply to positive 60 but add to positive 19? Well, that tells me that all my integers should be positive. If I'm multiplying to positive and adding to positive, all my integers should be positive. So I'm going to list 1 and 60, 2 and 30, 3 and 20, and then 4 and 15. And then I'm going to stop there. If you continue going on, you'll continue getting decimals until you loop back around to 15. Okay, so what two of these numbers are going to add to 19? That's 61. Nope. 32. Nope. 23. Nope. 19. Ding, ding, ding. That adds to 19. 15 and 4 multiply to 60 and add to 19. So my answer is going to be A, 5, N, variable. So A, variable, plus 4, times, running out of space here, A, variable, plus 15. 5 and 4 prime, 5 and 15, I can divide by 5. My two binomials is 5n plus 4 and n plus 3. Okay. All right, so those are 4 examples where A is not 1. And I'm going to scroll down. I'm going to let y'all do 5, 6, and 7 on your own on this page. But number 8 is going to be a little bit different. This is the hardest. This is the hardest of the trinomials where A is greater than 1, and this is why. If you look here, I always tell you step 1 is factor out the GCF. If you look here, each of these terms can be divided by something, a GCF. 9 is my smallest number, but 9 will not evenly divide into 66 and 21. But 3 will evenly divide into all 3 terms. So if I factor out a 3, factor out my GCF, my remainder is going to be 3k squared plus 22k plus 7. Now I factor my inside trinomial. A is 3, B is 22, and C is 7. What adds to B, what adds to 22, positive 22, what multiplies to AC, what multiplies to positive 21? Well, you should automatically look at those two numbers and know what? They're 1 and 21. Okay, 1 and 21 multiplies to 21 and adds to 22. So my two numbers are just that first factor, 1 and 21. So your answer, you cannot forget about your GCF. You've got to write your GCF in your answer. 3, and then A, 3, variable K. So 3K plus 1, and 3K plus 21. Divide each of these terms by 3. So your final answer ends up being GCF, my first binomial, 3k plus 1, and k plus 7. That is your final answer for number 8. Okay, so these are a little bit different. You've got to factor out your GCF. Once you factor out your GCF, you factor what's inside the parentheses here the way that we were doing numbers 1 through 6. Okay? And essentially ignore the 3 GCF until you have to write it in your answer. Okay? All right, so y'all are going to do numbers 5, 6, and 7 on your own. 5, 6, and 7 do not have a GCF. And I'm going to scroll down here and I'm going to go ahead and tell you which ones on the next page that you're going to do on your own have a GCF. Okay, I'm going to tell you which ones on the second page have a GCF. Number 9 has a GCF. And that GCF is 3. You can divide out a 3 of all 3 terms. Simplify and then factor. Okay, and then number 16. Number 16 has a GCF. And that GCF is just -1. You need to factor out the negative. That's one of the rules in factoring is you've got to factor out the negative. And then number 18. Number 18, I'm going to go ahead and give you that GCF. Number 18 has a GCF of 4. Each one of these terms, you can divide out a 4. You can divide out a 4.
Let's do it.
Hold on just a second. Okay, so I did numbers 1, 2, 3, 4, and number 8 for you on the first page. So you're just doing 5, 6, and 7. And then I told you the GCF of 9, 16, and 18. So you're doing 9 through 18. Now, if you scroll down here, you will have the answers that you can check off your work with. However, when I go in to check your work for the bonus for you VIP people, or for the face-to-face kids, you've got to show all your work here. In order to get your bonus points and get the full credit, you've got to show all your work just as I did here on numbers 1, 3, 4, and number 8. You've got to show all your stuff because obviously you got the answer. I'm giving you the answer. This section here is what I'm looking for. I'm looking for everything that's written for each problem, all your steps. You need to show all your steps for full credit.